All right, let's take a look at an example that applies the vertical angles theorem. Now that we just proved what it was, um, let's just see how it works in real life. So the diagram shows how glass lenses change the direction of light rays passing through a telescope. What is the value of x, the angle formed by the crossed outermost light rays through the focal point? So if we look at the picture, here's our focal point. Here's angle x over here. We want to figure out the measure of this angle, and we're given some other information. So angle x is being formed by, here are the two sides of that angle. What we want to notice in this picture is that we have a straight line here, a straight line there. So we have intersecting lines. When lines intersect, that means that you will have vertical angles congruent. So this angle up here is across from this angle down here. Those angles have the same measure. We don't care about those angles in this example, but it's just good to point out. Angle X right here will have the same measure. I'll go ahead and give some congruency arcs. We'll have the same measure as this angle over here. So if we can figure out what this angle is, then we know angle X will have the same measure. Well, this angle is formed by two smaller angles. Here's one of them, 11 degrees, and then here's the other one, 11 degrees. So you guys know that 11 plus 11 is 22 degrees. Oh, that was supposed to be, there we go, 22 degrees. And if angle X is congruent to that, that means X is also equal to 22 degrees because of the vertical angles theorem. So we had to first identify that the angles were vertical angles. We observed there were intersecting lines, and then we knew these angles across from each other sharing that vertex would be congruent.